Welcome here. This is Honors Geometry doing section 2.5. The objective for today is students will be able to use deductive reasoning to make conclusions. Section 2.5, like I said. So first of all, let's talk about what in the world is deductive reasoning. And so deductive reasoning is the process of reasoning logically and drawing a conclusion from given facts and statements. So deductive reasoning is a lot of what Sherlock Holmes does. For example, maybe you guys might be familiar with him, but you take just upon what is given, the facts and statements that are given, and you say, okay, well, reasoning from all of this, we're going to draw some different conclusions. Okay, and now sometimes we can draw conclusions, and sometimes we can't. But when we do, and we use these facts and statements, and we use logic to go from there, it is called deductive reasoning. You are deducing what is going on. So we have a couple of laws we're going to talk about today. We have two laws that make up deductive reasoning as we talk about it. So the first law will be the law of detachment, okay? And we're going to be detaching things from each other for our law of detachment. So given a conditional statement, if the hypothesis is true, then the conclusion is true. Now I should note that this is saying that the conditional statement itself is true. So if we're given really a true conditional statement, if the hypothesis is true, I forgot to finish my word hypothesis there. If the hypothesis is true, then the conclusion has to be true. In symbols, we can say we have our conditional statement, if P, then Q. P happens. So we have these three dots. These three dots just mean therefore. I'm going to even say that though. These three dots mean therefore. We can say because we had our true conditional statement, if P then Q, and because P, the hypothesis happened, therefore Q, our conclusion will happen. Now I have a video here to show us that I really think does a good job of explaining this law.
Today we're going to dive more deeply into deductive reasoning, which is also called logical reasoning. We're going to look at some given conditional statements to make facts or a conclusion. We're specifically going to look at the law of detachment and the law of syllogism. We're going to start with the law of detachment. It says that we need to identify the hypothesis. If another statement has the same hypothesis, then you can make a conclusion. Let's look at a given statement because then this will make a lot more sense. Let's say that we're given the statement, if there is lightning, then it is not safe to be outside. Well, then we're told that Preston is outside playing baseball, and then he looks up and he sees some thunder and lightning. Well, we could say Preston sees lightning from the baseball field. And see, it's not an exact match to our original conditional statement, but it's the same idea. The hypotheses are the same. If there is lightning, Preston sees lightning. Well, then we can make the same conclusion. It is not safe for Preston to be outside. Now, let's take a look at the same conditional statement. If there is lightning, then it is not safe to be outside. But this time, we're going to do a restatement of the conclusion rather than the hypothesis. It's not safe for Preston to be outside. Well, you know what? There could be a lot of reasons why it's not safe for Preston to be outside. Well, what if there are lions roaming around? Definitely not safe to be outside. Or what if there's a big, huge windstorm? Whoa, definitely not safe. Well, what if there are little green alien men running around all over the place? Definitely not safe to be outside. Well, again, there could be a million reasons why it's not safe to be outside. We just cannot make a conclusion when there's a restatement of the conclusion. So, to summarize, the law of detachment says that we need to identify the hypothesis. If another statement has the same hypothesis, we can make a conclusion. Putting it into our symbolic notation, if P, then Q is true, and P is true, and again, P is just a restatement of the hypothesis. It doesn't have to be word for word verbatim. Well, then Q is true.
Alright, so that video I feel like it does a really good job of talking through what happens and just kind of explaining that just because the conclusion happens doesn't mean that the hypothesis happened though, okay? That can be a common misconception. So let's use this law of detachment to give a valid conclusion. So we're given a conditional statement. If Mark saves $30, then he can buy a new video game. So something that they did in the video a lot was identify the hypothesis and conclusion. They talked about that. Mark saves $30. That's the hypothesis. It's our P. It follows the if. Then he can buy a new video game. So what follows then? He can buy a new video game is our Q. Mark saves $30. That's our P. So this follows our guide for the symbols word for word here. We have like true conditional statement and we have a restatement of the hypothesis. So what's the conclusion we can draw? Well, since Mark saved $30, Mark, or he, can buy a new video game. He can buy a new video game. On number 2, if a quadrilateral is a rhombus, then it is also a parallelogram. So again, we're going to identify our hypothesis and conclusion. Quadrilateral is a rhombus. That's our hypothesis. It is also a parallelogram. Is our conclusion. Well, quadrilateral ABCD is a rhombus, so we have a quadrilateral being a rhombus. And just like she said in the video, it doesn't have to be word for word, okay? But we have a restatement of our hypothesis. So our conclusion is that quadrilateral ABCD is a parallelogram. Continuing on, we have number 3. If you are 18 years old, then you can register to vote. Well, you are 18 years old is P. You can register to vote is Q. Now we're told Olivia is not 18 years old. This is not P. Now anytime we have anything other than a restatement of the hypothesis, it is going to be no valid conclusion. We can't say that Olivia can't register to vote. Just because she's not 18 doesn't mean she can't register to vote. So there's no valid conclusion. Olivia could be 19. She could be 20 or 21 or anything older than 18. That's kind of like the Preston playing baseball. Just because there's not lightning, there could be a giant windstorm or aliens or you name it. Number 4, if the sum of the measures of two angles is 90 degrees, then they are complementary. Sum of measures of two angles 90 degrees is our P. They are complementary as Q. Measure of angle J equals 58 degrees and measure of angle K equals 32. Now is this a word for word restatement at all? No. What do we know about 58 and 32? Could we add those and get 90? We certainly could. So we'll say, in a way, this is the hypothesis. So what's our conclusion? We can say that angle J and angle K are complementary. 5. If you plan to attend prom, then you must purchase a ticket. Well, you plan to attend prom is our P, and then you purchase a ticket is Q. Sarah purchases a ticket to prom, or purchases a prom ticket. That's Q. Well, Sarah purchased a prom ticket. Does Sarah plan to attend prom? We might say, well, yeah, probably, but we don't actually know for sure. We have no valid conclusion. Because it was not the hypothesis stated, we can't say that there's a valid conclusion. Now I might be saying, Mr. Kossel, what in the world would happen here to where it wouldn't be that Sarah's going to prom? Well, maybe she bought the ticket for someone else. Maybe her friend is going and she's not, but her friend wasn't able to buy the ticket on time because she was gone the last day of school that they were selling tickets. So maybe she's buying it for a friend. We can't rule out other possibilities, unfortunately. Continuing on, now we're going to talk about the law of syllogism, and we'll finish up the video after we write down what the law of syllogism is. So the law of syllogism, as a mouthful, allows you to draw a conclusion from two conditional statements, in which the conclusion of the first statement is the hypothesis of the second statement. So how one of them ends is how the second one starts. So in symbols, we have if P then Q. We have our first conditional statement. Then we have our next conditional statement, if Q then R. So we have the conclusion of the first matching the hypothesis of the second. So we have the three dots. Therefore, we have if P then R. We use kind of Q to kind of link them through, so to speak. We skip from P all the way to R using the law of syllogism. And we'll finish off that video here.
Well, now let's look at the law of syllogism. And it says you can make a conclusion if the hypothesis and conclusion from two conditional statements are the same. Let's look at an example, make a lot more sense. Let's say we're given the statement, if everyone does their geometry homework, then they will pass geometry. If everyone passes geometry, then Mrs. Gray will have a party. Well, we can conclude then that if everyone does their geometry homework, well then, voila, Mrs. Gray is going to have a party with lots and lots of cake. Well, let's look again at our original statements. There is a match. We have a hypothesis that then we will pass geometry, and another match if everyone passes geometry. Well, we basically have just crossed those out and combined our hypothesis that we started with and our conclusion that we ended with. We just crossed out the matches and combined what's left over. If everyone does their geometry homework, then Mrs. Gray will have a party. So to summarize, the law of syllogism says you can make a conclusion if a hypothesis and conclusion from two conditional statements are the same. And that's again where we saw that match. And putting it into our symbolic notation, if P then Q, if Q then R, well then we can conclude then if P then R. Again.
Alright, so I think that video explains it well, that it really kind of links the two statements together. Only works if the conclusion of the first matches the hypothesis of the second, because you can cut out the middleman, so to speak. So let's go through some examples on this one. So you use a law of syllogism to draw a valid conclusion. If not, write no valid conclusion if you can't. So if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. Let's go through and mark our P, Q's, and R's. It is Saturday. That's our first hypothesis. Jake has a baseball tournament. That's our Q. Now, Jake has a baseball tournament. We've seen that before. That's Q again. So we're not going to use a new letter. We're going to say Q, it stays the same. Then he will need to pack his lunch. That's new though. So we use R. So this does follow if P then Q, and if Q then R. So this is a perfect example where we can use our law of syllogism to sort of cross out our Q's and go if P, then R. So we can say if it is Saturday, then Jake will need to pack his lunch. Notice I put Jake instead of he just because we don't know that Jake right now. We don't know who he is if we don't put it. Then Jake will need to pack his lunch. And now during this video, if you want to pause at any point and go back or and rewind anything, or if you need to speed up if going a little too slowly for you, feel free to. If you want to pause, try a problem, and then unpause and see how you did compared to mine, that'd be an excellent thing to do. Okay, but we're able to go straight from P to R saying, hey, if it's Saturday, Jake's going to need to pack his lunch. Because that means he already has a baseball tournament, so he needs a lunch for the tournament. We can cut out all that fluff. Let's look at number 7. If a number is divisible by 12, it's divisible by 6. If it's divisible by 6, it's divisible by 3. So a number is divisible by 12, that's P. It is divisible by 6 is Q. A number is divisible by 6, we've seen this before, it's our Q. It is divisible by 3, that's our R. So it does go if P then Q, and if Q then R. So this follows our pattern. So we can say, hey, if P then R. If a number is divisible by 12, then it is divisible by 3. And that is a true statement. You can divide a number by 12, you can divide it by 3. Let's look at number 8. If a quadrilateral is a square, okay, I'm going to go and start here. Quadrilateral square is P, then it is a rectangle. It is a rectangle's Q. We haven't seen that yet. If a quadrilateral is a rectangle, okay, it's not word for word the same as Q, but it meant quadrilateral. So it really is saying quadrilateral is a rectangle. So that is Q. Then it has 4 right angles, R. So this once again follows our if P then Q, if Q then R. So we can go if P then R. So if a quadrilateral I don't know what happened there. Alright, let's undo that part. There we go. If a quadrilateral is a square, comma, then it has 4 right angles. And that's a true statement as well. Continuing on, number 9. If it is sunny this weekend, then you will go boating. That's P. If it is sunny this weekend, you will go boating. Q. If it is sunny this weekend, we've seen it is sunny this weekend. That's P. It's not Q. It's P. Then you will wear shorts. You will wear shorts. That's new. It's R. So this one goes. Let me fix that again. This one goes. Let's make that R. This one goes if P then Q, and it goes if P then R. So that does not follow the same pattern. The conclusion of the first and hypothesis of the second don't match up. So this is actually no valid conclusion. You can't make any conclusion. Mr. Costle, can't you say that if you go boating, then you're going to wear shorts? Well, you might think that, but what if it's not sunny that day? What if it's a little bit colder? You might go boating and wear, I don't know, long pants. It might be weird, but I'm sure someone's done it. So you can't draw any conclusion using this law of syllogism. Without knowing any additional details, we can't say anything comes from it. 10. If you shop at Target, then you will use your Target Red Card. Okay, well, you shop at Target, it's going to be P. You will use the Target Red Card, we're talking about Q. It's a new one. If you do not use your Target Red Card, then you will not get 5% off. So you do not use your Target Red Card. That's going to be not Q. Notice I add the word not. Then you will not get 5% off. And that's just going to be R. Now, Mr. Cossel, as not, shouldn't it be not R? Well, that's a good question. But it'll just say normal R. Because we're allowed to have a statement have not in it. But when we see the statement originally, like Q saying you will use it, and then we see another statement later saying you won't use it or you do not use it, that's when we put the negation, when we see a change. Here, this goes if P then Q, and it goes if not Q then R. Well, even though we have Q and Q, they're different because one's normal and one's not Q. So we cannot draw a conclusion. Can't say anything about, hey, if you shop at Target, you won't get 5% off. Well, because what if they did bring their red? What if they did use their Target red card? We're going to skip 11. Okay, you can always go back and do it if you want and ask me about it later if you'd like. More practice. Whoop, whoop. Okay, so we have our law of detachment, law of syllogism, and we have our symbols written again there, okay? So I like to say law of detachment to keep this straight. Detach. You're taking something away. You're detaching it. So we have if P then Q, then you have if P, and then you just have P, and then you have Q. It's like you detach them from each other. Whereas law of syllogism, you end up having two complete if-then statements, two complete conditional statements, and your answer is another conditional statement. Whereas law of detachment, you have a complete conditional followed by just hypothesis, and your conclusion is just a conclusion. So it's like you detached the hypothesis and conclusion from each other. So determine whether the conclusion follows from the given statements by the law of detachment or the law of syllogism. So which law is used? And if it does follow from one of them, if it doesn't follow from one of them, state not valid or invalid. So we're given, if I drive over the speed limit, then I would get a ticket. I drive over the speed limit, that's P. I will get a ticket, that's Q. I drove over the speed limit. That looks like P again. So let's look. This looks like so far, it's going to be like the law of detachment. We have if P then Q, and we have just P by itself detached or separated from Q. So I got a ticket. Does that follow Q? It does, in fact. So this is going to be the law of detachment. Once again, my pen decided to be weird here. It's going to be the law of detachment. You need to follow that pattern. Let's look at number 2. If Amanda goes to the restaurant, then she will order a hamburger. Well, Amanda goes to the restaurant, that's P. She will order a hamburger, that's Q. If she orders a hamburger, then she will get fries. So she orders a hamburger, we've seen that, that's Q. She will get fries, that's new, it's R. If Amanda goes to the restaurant, okay, excuse me, before I go there, this looks so far like it's going to be the setup for the law of syllogism. If P then Q, if Q then R. It's two complete conditional statements with the conclusion of the first matching the hypothesis of the second. Let's see if the conclusion that we draw from this matches up. If Amanda goes to the restaurant, okay, that's P, then she will get fries, R. So that is what it's saying. The law of syllogism does make this valid. So this is using the law of syllogism. Now, if it had said if Amanda goes to the restaurant, or if Amanda gets a burger, then she ordered. Let me scratch that real quick. If it were to have said if she gets fries, then Amanda went to the restaurant. Well, we don't know that to be any sort of conclusion. We have to actually say invalid, because she could have gone to, I don't know, this grocery store and bought fries and put them in the oven. But it didn't. It just said, hey, it followed the pattern. If P then Q, if Q then R, cut out the middleman. Let's go straight from P to R. Number 3, if it snows, then I will wear my snow boots. It snows, that's P. I will wear my snow boots, that's Q. If it snows is P again. Then I won't go to school that day. That's R. So we have if P then Q, if P then R. So far, this doesn't really look like it actually is either of them. We don't have the second being a detached hypothesis, and we don't have the second one being the conclusion matching of the first matching the hypothesis of the second. Let's finish it out though, just in case. If I don't go to school, okay, well that's R, we've seen that before, then I will wear my snow boots, that's Q. So this follows nothing that's going on here. The beginning doesn't set up to follow it, the conclusion doesn't match. This one is invalid. Somebody used one of these laws improperly. It looks like someone tried to use the law of syllogism improperly. Continuing on. We will do 4 again. Okay. If Tina goes to the beach, Tina goes to the beach is P. She will wear sunscreen. Okay. She will wear sunscreen is the Q. It looks like it's missing the then there, but we'll imagine that it's there. Tina goes to the beach. That's P. So this already looks like the setup for the law of detachment because we have a P detached from the Q. Tina will wear sunscreen. That's our Q. All right. So this is the law of detachment at work. Look at 5. If you get a cold as P. Then you eat chicken soup. That's Q. You ate chicken soup. Q happened. Now wait. This looks like a setup for the law of detachment, except for we have our conclusion detached from the hypothesis rather than the other way around. We can't draw the fact that you have a cold from the fact that you ate chicken soup. Maybe somebody just likes chicken soup and they ate it even when they're healthy. So we have to say, nope, this is invalid. You can't use either of the laws to make this conclusion. All right, continuing on here. This is our last page here, okay? We'll do 6, and then we will do 8, okay? We're going to skip 7. Actually, we're going to skip 8 as well. If 2 angles form a linear pair, then they are supplementary. 2 angles form a linear pair, that's P. They are supplementary, that's Q. If 2 angles are supplementary, hey, that's Q again. Then the sum of their measures is 180 degrees. The sum of their measures is 100 degrees, that's R. So far this looks like it's set up for the law of syllogism. P, if P then Q, if Q then R, and the Q's match up there. The conclusion of the first matches the hypothesis of the second. If 2 angles form a linear pair, that's P, then the sum of their measures is 180 degrees. That's R. So we have if P then R. So this is the law of syllogism at work. Like I said, we're skipping over 7 and 8. Number 9, our very last example in our notes today, okay? Then on to some homework. Whoop, whoop, we all love that, okay? Use the law of syllogism to write 3 conditional statements that can be formed from the following true statements. If a quadrilateral is a square, then it has 4 right angles. If a quadrilateral is a rhombus, then its opposite sides are parallel. If a quadrilateral has 4 right angles, then it's a rectangle. If a quadrilateral is a rectangle, then its opposite sides are congruent. If the opposite sides of a quadrilateral are parallel, then it is a parallelogram. So if we link these 5 together, let's first go through and highlight what's happening. A quadrilateral is a square. We can call that P. Then it has 4 angles, right angles. That's Q. Let's start the next line. If a quadrilateral is a rhombus, let's go through and highlight all of these. Well, that's a new one. We'll call that R. Then its opposite sides are parallel. That's new again. We'll call this S. So our first one goes if P then Q. Our second one goes if R then S. Letter C, a quadrilateral has 4 right angles. If a quadrilateral has 4 right angles, we've seen that before. That's Q. Then it is a rectangle. Well, that's new. Okay, we'll call that T. Try that again to call it T. There we go. So we'll say this one goes if Q, then T. Letter D, if a quadrilateral is a rectangle, that's what we called T earlier, then its opposite sides are congruent. That's new. Let's call this U, our next letter. We'll just keep going down the alphabet. So this one goes if T, then U. If the opposite sides of a quadrilateral are parallel, then it is a parallelogram. The opposite sides of quadrilateral are parallel. That's going to be S again. Then it is a parallelogram. Well, that's a new one, so we're going to have to call that V. So this one goes if that S, then V. So we're saying, can we make some sort of combination between these in order to make a law syllogism? Well, you might notice if P then Q, if Q then T line up. So you could say, well, the first one could be if P then T. We can say if a quadrilateral is a square, then it is a rectangle. If a quadrilateral is a square, then it is a rectangle. That could be one conclusion we make. Let me switch to a different color here for another conclusion we could make. You might notice if Q then T, and if T then U. The T is the conclusion of the hypothesis of the second one. We could line those up and say, hey, if Q, then T. So we can say if it, so if a quadrilateral, that's the it it's talking about, if a quadrilateral has 4 right angles, then, I said if Q then T, excuse me, you're all probably wondering what I did there, okay? That shouldn't be T, that should be if Q then U, okay? So if quadrilateral has 4 right angles, then its opposite sides, I'm going to abbreviate opposite into OPP, opposite sides, keep pushing a button that makes that error happen. And opposite sides are congruent. Well, for our next one, our last one, we really could do a number of different things. So we could try and link up if R then S, and if S then V, and go straight from R to V. Another one we could do that I'll show you, it's kind of a neat thing, okay? Is we can actually link up multiple things at once. Okay? Oop, not meaning to erase that. Okay? We could actually link multiple things at once. So if I wanted, I could link if P then Q, if Q then T, and if T then U. And I could get rid of my Q's and my T's and go straight from P to U. And I can say, okay, well, hey, if a quadrilateral is a square, then its opposite sides are congruent. So we can actually kind of use a law of syllogism twice, or even more if we had more link up. Okay, so we can kind of use a law of syllogism multiple different times there. Now this does conclude our notes for today. Okay, this does conclude our notes for the day. So now would be the time to start working on that homework. Okay, so if you're in class, go ahead and grab it for me. If you're not, we'll go ahead and just pull it out of your backpack or your folder, wherever you have it, and work on it now because I should have handed it to you earlier. And if you weren't in person or you don't have the homework for whatever reason, you can always look on Google Classroom and try it on a separate sheet of paper or print it if you have the option.